it's a parallelogram where E and F are the midpoint of the side AB and CD. Show that line segment AF and EC trisect the diagonal BD. So basically we want to prove here that the diagonal BD is getting trisected. Bisected means getting cutted in two equal parts. Trisected means getting cutted in three equal parts. So the diagonal BD is getting cutted in three equal parts. This is X, this is X, this is also X. Like each and every measurement are same. That's what we have to prove over here. Okay. To prove it, first thing first, we will be proving that this red portion, this is a parallelogram. First thing first, we will be proving that this is a parallelogram. How we will be doing so? So we are saying that since we already know that this blue and this blue are parallel. So obviously the part of it will be also parallel. That means this much part and this much part will also be parallel. These two are equal also. Why these two are equal? Because AB is equals to CD. It's a parallelogram. That means half of AB and half of CD will also be equal with each other. Once we have proved that these two blue lines are parallel and are equal also, it's a parallelogram. Okay, the red colored part which I started painting in the beginning of the discussion only, the red colored part totally, it's a parallelogram. We have proved that. This much is clear to everyone.
Yes, ma'am.
Now we are going to prove that how it is trisecting. Let's see. So now we are going to take the yellow triangle and the green triangle. First thing first, let's focus on the green triangle. In the green triangle, F is the midpoint. We already know. Okay, in the green triangle, if I am drawing the green triangle separately like this, the name was CD. Here F was the midpoint, which is already given in the question that E and F are midpoint of AB and CD. So F is the midpoint. And we know that through F there is a line which is going like this, which is parallel to this line. This one and this one are parallel. Why it's parallel? Because now only we have proved that I painted those portion as a red color portion, and I was saying that it's a parallelogram. So obviously this much and this much will also be parallel. Yes or no?
Yes, ma'am.
In a triangle, if one of the sides, like if we are drawing a line through the midpoint of one of the side parallel to the other side, it will bisect the third side. So the third side, that is, okay, the name I have not written correctly. CD is just here. Here is C, here is D, and here is Q. Let me check. Yeah. So this is FP. So if F is the midpoint and if FP is parallel to CQ, then P will also be the midpoint of DQ. Yes or no? The converse of the midpoint theorem says if we are drawing a line through the midpoint of one of the side of a triangle parallel to the other side, if you are drawing the line through the midpoint of one of the side, that is side CD midpoint, we are drawing a line. That line is parallel to CQ. Then that line will touch other sides also, the third sides also midpoint, right? That's what the converse of the midpoint theorem says, right?
Yes, ma'am.
We can say P is the midpoint of DQ. That implies DP, DQ are same. That implies DP, DQ are same. Okay. This length and this length are same in the green triangle. Similarly, now we will be focusing on the yellow triangle. In yellow triangle, we know E is the midpoint, right? E is the midpoint of side AB, and EQ is parallel to AP. Yes or no?
Yes, ma'am.
Then Q must be the midpoint of the third side of yellow triangle. What is the third side of yellow triangle? The third side of yellow triangle is this much only. Okay, PB. PB is the third side of yellow triangle. If you wanna draw the yellow triangle separately, you can draw it like this. The name is A, B, P, and through the midpoint of AB, that is through E, we are drawing a line. That line name is EQ. EQ is parallel to AP. So through the midpoint and the parallel also, then Q must be the midpoint of BP. Okay. So BP is equals to BQ. We got that BP DP PQ was there, and now we are saying BP is equals to, okay, it's not BP. In yellow triangle, we are saying that the PQ, this length, this length and this length will be same because Q will also be the midpoint by converse of midpoint theorem. So we are saying that Q will be the midpoint of BP. Let's write that at first. Q is the midpoint of BP. That means PQ and BQ are same. That means BQ and PQ are same. Now from equation 1 and equation 2, can I say that BP, BQ, PQ all are same? Can we say from 1 and 2? Can we?
Yes, ma'am.
DP, BQ, PQ. Let's see. DP, BQ, PQ all are same. That means the diagonal BD is getting trisected, right? Trisect the diagonal BD, right? So our diagonal BD is getting trisected since we have proved already that DP, PQ, BQ all are of same length. Now let's summarize what we have done. Okay, so we were having over here a quadrilateral A, B. Okay, we were having a parallelogram, not a quadrilateral. We will have ABCD is a parallelogram where E is the midpoint of AB and F is the midpoint of CD. What we wanted to prove? We wanted to prove that this was the figure which was already given in the in the question itself. We wanted to prove that the diagonal BD is getting trisected by these two lines AF and EC. The diagonal BD is getting cutted in three equal parts. Okay, that means we wanted to prove over here PQ that DP, PQ, BQ all are of same length. We want to prove that DP, PQ, BQ all are same length. Okay, diagonal BD is trisected. That's what we wanted to prove here. Now what we did, first thing first, we have proved that this one is a parallelogram. This total this purple one, it's a parallelogram. First thing first, we have proved that, and it was very simple to prove it's a parallelogram, because we have just proved here that FC is parallel to AE and FC is equals to AE. This too we have shown, and we said that this is a property of parallelogram only. Hence AEFC is a parallelogram. Okay, so first thing first, we have proved that AEFC is a parallelogram. Now we have taken the help of midpoint theorem to prove that DP, PQ, BQ all are same. How we have taken the help of midpoint theorem? So here we can see one triangle, the yellow triangle we have taken, and converse of midpoint theorem we have applied. And we are saying P is also the midpoint of this yellow triangle. Of this yellow triangle, side DQ is having the midpoint P. That's what we are proving just by writing the theorem, that is converse of the midpoint theorem. Now P is the midpoint that we have proved, that is giving us P is the midpoint of this yellow triangle side DQ. That means DP is equals to PQ. We have proved by midpoint theorem. Now we are going to take the another triangle, that is the green triangle, this triangle. And the same thing we are repeating in this green triangle, and we are saying Q is the midpoint. So we are saying that Q is the midpoint of the third side of the green triangle. That means PQ, BQ are same. Now we are just combining this, and we are saying DP, PQ, BQ all are same. Hence the diagonal BD is getting trisected. Is it clear? Any confusion?
No, mom.
So this is how we can prove that the diagonal BD is getting trisected by line AF and EC. Now, if you are having any query from here, any doubt from here, please do ask. I'm going to start the next chapter, that is surface area and volume. Anyone want to ask anything from here? Anyone?
No, mom.
Okay, let's start surface area and volume. For surface area and volume, first thing first, you need to understand what exactly is the meaning of the surface area and what exactly is the meaning of this volume. Okay, so first thing today we will be discussing majorly about surface area and the formula of surface area of each and every figure. Now just give me a second. I'm showing you one picture. Can you see this book?
Yes, mom.
Which shape is this?
Keyboard.
It's a cuboid. And what's the meaning of surface area of this cuboid?
Surface is how much, uh, like area is how much space it occupies, maybe.
Yeah. Surface area basically means that area of each and every surface. So how many surface we can see here? One surface, another surface. Okay, then one more, one more, and one more. So total six surfaces there. Can I say four? All the four side and top and bottom, six surfaces are there. Yes or no?
Yes, mom.
Once we will take out area of each and every surface, which is, you can see, rectangular in shape. This surface is rectangle, this surface is also a rectangle, this is also a rectangle, this is also a rectangle, and this is also a rectangle. So each and every rectangle's area you will find, and you will add all of them together, then you will end up getting the total surface area of this cuboid. Getting it?
Yes, ma'am.
So let me draw the figure. We are having a cuboid which is made up of rectangles only. What is the surface area of cuboid's formula? Anyone? What's the formula for surface area of the cuboid? Don't know? It's 2 times length into breadth, breadth into height, height into length. This is the formula. We are going to discuss from where exactly this formula came out. So as I said, you should understand the meaning of surface area, because randomly just after this one, I will start drawing another different types of figure, combination of two figure. You should understand surface area means area of each and every surface added together or combined together. So how we got this formula for the surface area of cuboid? Let me show you. Can you see this rectangular surface? Can you see?
Yes, ma'am.
This surface is just a rectangle where length is L and breadth is B. So here area of this rectangle will be length into breadth, L into B. Similarly, the top one is just like the bottom one where length will be there, breadth will be there. So area of this one is also length into breadth. Now what about the area of other rectangles which this cuboid is already having? So if I am talking about area of this rectangle, this green rectangle, if we will be focusing on area of this green rectangle, this is having one of the measurement as a B, and another measurement of this green rectangle will be the height H, because this cuboid must, when we are talking about solid figure, three-dimensional figure, it must be having height. It is not flat just like the two-dimensional shape. The two-dimensional shapes are flat figures where it's just a flat plain figure. Once you will be pouring water on it or anything on it, it will just flow out. But three-dimensional shape will be having its capacity. Okay, it will be having a height as well. Okay, so here we are going to discuss about three-dimensional shapes only, or you can also say here we are going to discuss about the solid shapes. Okay, so this, we are basically discussing about solid figure. Solid figure in mathematics is called three-dimensional figure. Three-dimensional figure must be having a proper height. So once we are talking about cuboid, you can see here the height of the cuboid is also there. It doesn't have only two measurement. Here we are having three measurement. That's why the name is three dimension. Dimension means measurement. So three dimensions we are having: length, breadth and height. All the three can be same, can be different, doesn't matter. But three measurements will be there. Okay, so here we are having the height of the cuboid as well. Now if you will be focusing on this green triangle, then you can say this green triangle is having one of the measurement as a B. Oh sorry, triangle I'm saying, it's a rectangle. The green rectangle is having one of the measurement as a B and another measurement as a H. Can you see?
Yes, ma'am.
That's why this green rectangle, if we will be finding the area of this green rectangle, it will be B times H. Similarly, on the other end also you will be having same green rectangle like this one, and that one's area will also be exactly same like this green rectangles area, and that will also give you the area as B into H, because here we have to take the consideration of height as well. Okay, so this will also be having the area as B times H. Now, what about the front portion and the back portion? We have discussed about the bottom part area, the bottom rectangle area, and the top rectangle. Both are same and both are having the area length into breadth. The left side's area, the green sides area, and the right sides area, both the area is breadth into height, breadth into height. Now the front and the back. So when we will be focusing on the back portion, if I am going to color the back portion, this one, the yellow one, here you will be able to see two measurement. One of them is height, another is length. Okay, so from there only the formula for the area, like the area for that part, the front and the back part will be, for this yellow one, the area will be, height is there, if you can visualize, height is involved over there and length is involved over there. Okay, for this rectangle, height, and this total will be the length. Okay, so for the yellow one, area will come out, the rectangle's area, that is height into length. For the front, in the front also we are having the same yellow rectangle, which I am not coloring, otherwise everything will just get mixed up with each other. So in the front also we are having the same rectangle like the yellow one, and that area will also be H into L. And from there only the formula came out. From there only the formula came out, that length into breadth, again length into breadth for this one, breadth into height, breadth into height, height into length, again height into length. Once we will be adding all of them, length into breadth for the bottom one, length into breadth for the top one. Then the green colors rectangle area is breadth into height. Other green colors rectangle area is, the right hand side part area is same, breadth into height. The yellow part, the yellow shaded portion area from here is H into L. And in the front also we are having one yellow portion which I have not colored. That area will also be H into L. And from here only, once you will be adding all of them together, you will be having 2 times length breadth, 2 times breadth height, area of all the 6 portion, all the 6 surfaces. One of the surface, another surface, another surface, another surface, another surface, another surface. Area of all the surfaces combined together or added together will give us the total surface area of this three-dimensional set. That is 2 times length into breadth, breadth into height, height into length. This is the formula which your book, like in your book, you can see this formula and you need to memorize this formula. What was the whole explanation? The whole explanation was related to from where exactly this formula came out. Clear?
Yes, ma'am.
So now you must have understood, if I will remove the top part from this cuboid, that means you just, if you understand from where exactly the formula is coming, and the same figure I am giving you now and telling you the top part is not covered, there is nothing on the top part, so you will understand, okay, the top part area was length into breadth, so from this formula we have to exclude, we have to subtract length into breadth if the top part is not covered. Getting?
Yes, ma'am.
Now the surface area of the cube. Surface area of cube. Now this cube is made up of squares. Okay, so all the side which was rectangle for cuboid, now this all the sides are square for cuboid. So that's why we are having each and every, this is a, length is a, breadth is also a, and here for the cuboid height is also a, everything is a. So the way we were finding the area of left hand side portion, the right hand side portion, the bottom portion, the top portion, the back portion, the front portion, here each and every area will be the square seats area, that means a square. So here you will be having 6 times a square, a square, a square, a square, a square, a square, because each and every surfaces are just a square. Length is also a, breadth is also a, height is also a. So no need to worry about L into B or B into H or H into L. Everything is A into A only. Okay. So from here we got the formula 6a square, and that is the surface area of cube's formula, that is 6a square. What is a? Side. Got it?
Yes, mom.
You need to memorize these formulas only, and the explanation behind that you just need to understand that. Now the third three-dimensional shape we are having today is surface area of cylinder. Now how can we make a cylinder? We can take a rectangular sheet of paper like this. Okay, and we are going to fold it. Can you see a cylindrical shape over here? Everybody, can you see a cylindrical shape?
Yes. Yes, mom.
Now we are going to find the surface area of the cylinder. How we will be doing so? Earlier we were having a rectangular sheet. Now we are folding it and making a cylinder out of it. So let me make a rectangular sheet at first. We were having a rectangular sheet whose area will be, if length is L, breadth is B, area will be L times B. Now we are just folding it and making a cylinder out of it. So we are folding it and making a cylinder like this out of it. And we are thinking about what will be the surface area of this cylinder. Now the bottom part, which was only length, this was the length. This I am folding it and making a circle at the bottom. Can you see the length I am using? The rectangles, previously it was rectangle, that rectangle which was having the length L, that I am using to make a circular end, right?
Yes, mom.
The length is getting utilized into a circle, and that too, once you will focus on my finger, you can see it's the circumference of the circle. Yes or no? Can you see the
Yeah.
circumference of the circle? We are just making the length as a circumference of the circle. So basically the length is getting changed to circumference of the circle in the cylinder. Length became 2 pi r. What is 2 pi r? Circumference of the circle. Why circumference of the circle? Because we are using the length to make the circumference of the circle. What about the breadth? The breadth of the rectangle, we are using it as a height. Okay, if you can see, again my rectangular sheet, this was the breadth. Now I am folding it. Can you see it is just getting the height of the cylinder?
Yes.
Can you? So the breadth or the width, whatever you say, that we are utilizing and making it as a height of the cylinder. Now the area, the previous area of our rectangle was length times breadth. Now this area will get customized into Length means 2 pi r and breadth means h. Hence, the formula for surface area of the cylinder is 2 pi r h. From where it came? It came from the circumference and the height product. Getting it?
Yes, ma'am.
This is how we are getting, or this is how we have got the formula for surface area of the cylinder. Now let me remind you whatever we have discussed, the formulas. The formulas which we have discussed till now, the formulas which we have discussed till now is the surface area of the cuboid. The formula is 2 times in bracket length into breadth, breadth into height, height into length. Surface area of cuboid. First thing first, we have discussed that. You should memorize this formula. Surface area of the cube's formula is 6a square. A is the side, and how we have got 6a square, you already know. You just need to memorize the formula. Surface area of the cylinder's formula is 2 pi RH. Okay, and if you have just kept in mind this much thing, let's move ahead and let's discuss about the next three-dimensional shape, that is surface area of a cone. Now, what is cone? Surface area of cone. In your day-to-day life, no, this figure, you always see this figure all around you. The conical structure can be the example of cone can be ice cream cone or your mehendi cone or your birthday cap. These are the examples of conical shape. Cylindrical shape example are glasses, bucket, or anything which is in the shape of cylinder. Like I am having my pen holder in the shape of cylinder only, which I can show you. Can you see the cylindrical shape? Can you see?
Yes.
It's a cylinder only. Okay, so yeah, all around us we are having this three-dimensional shape. That's why mathematics says let's understand this figure, let's know more about it, so that like in future when we will be just dealing with different types of shapes, we will be able to work on that. Okay, so surface area of cone. Now how we will be having a cone, just give me a second, let me draw the figure properly over. So we are having a conical shape like this. Okay. Now if I am going to open this cone here, let me open it. We are just going to cut this cone like this. Are you able to visualize it? How we are cutting it? Earlier it was like this. Now from one of the end, let's say from here, I have cutted it. Okay. Once we have cutted it like from here, it just took the shape of the second figure. Are you understanding?
Yes, ma'am.
Now, if we will open it completely, it will take the shape like this. This is A and this is B. If we will open it completely, it will take this type of shape. The third figure. Getting it? Are you understanding?
Yes, ma'am.
So earlier it was like a birthday cap. Now we have just cutted it from one of the point and then we ended up getting A and B. Now the A and B again I have written on the third figure so that you can relate with that. Once we will open completely, it will take the shape like this. Now we have to find the surface area. Oh yeah, one thing we have missed about the surface area of the cylinder. Let's do that and then only we will be coming here. So here surface area of the cylinder formula is 2 pi RH. This is the curved surface area formula. Okay, we say curved surface area formula, curved surface area of the cylinder's formula is 2 pi RH. What's the meaning of curved surface area? As the name says, curved surface area, that means once I am just making a cylinder like this, okay, the curve part, can you see this is the curve part? So this curve part surface area formula is 2 pi RH, but there is like two more part which there are two more surfaces whose area we need to consider over here. If you will see this top part and the bottom part, if I will take a circular lid and will cover it, if I will take a circular lid and will cover it, then we will be having how many surfaces? Surface area means area of each and every surface combined together. So if I am taking a circular lid covering it, if I am taking a circular lid and covering it, that time you will be having more than curved surface area. Let me show you. If you are having a cylinder like this, and if you are just covering it from the top and from the bottom, okay, with a circular lid, so you have to also take the consideration of area of this surface, area of this surface, and area of the curved surface obviously. So curved surface area already we have discussed, that is 2 pi RH. But if the cylinder is covered completely, or if say the cylinder looks like my cylinder, the pen holder, okay, where the you can see the top part is covered only. Can you see in the figure? There is a black part, okay. Here also a black part is there. Can you see? It's covered
Yes, ma'am.
already. So for this type of cylinder, total surface area will be the curved surface area and this area, because this much surfaces I can touch, I can feel. So surface area means area of each and every surface added together. So 2 pi RH, the curve part. This is a circle, pi r square. This is a circle, pi r square. We will be adding all of them together to get the total surface area of the cylinder. What's the formula for that? The formula for that is, let me wipe out this rectangle. The formula for that is total surface area of cylinder is 2 pi RH, the curved surface area, plus pi r square upper part area, pi r square lowers the bottom circle's area, is equals to 2 pi RH plus 2 pi r square. That means 2 pi r common factor we can take, and h plus r, or you can say 2 pi r plus h. This is the formula for total surface area of the cylinder. You have to be specific, you have to understand the question properly, to whether the question is talking about the curved part of the cylinder or the total surface area of the cylinder. Accordingly, you will use the formula. For curved surface area, the formula is 2 pi RH. For total surface area, the formula is 2 pi R in bracket R plus H. From where 2 pi R in bracket R plus H came out? It just came out just after the addition of upper part, upper circle area, bottom circle area, and by taking out few things common over here and there. Okay, is it clear? So for cylinder, we are having two formulas: surface area, that means curved surface area, and total surface area. You have to read the question carefully to understand whether you are going to find the curved surface area over here, or you are going to find the total surface area over here. Got it?
Yes,
Yes,
ma'am.
ma'am.
Now we were discussing about the conical shape, which I have cutted like this. Now I want to say that the last part, the last figure, I'm going to make a triangle out of it. So I'm just making a triangle like this. Okay. The name of the first triangle I am giving as a A1 triangle. Okay. Now one more triangle I'll be cutting over here. The name of the other triangle is A2 triangle. Okay, I'll be cutting one more triangle. All same measurement I am cutting the triangle, and the name of the third triangle is A3 triangle. Similarly, I am cutting one more triangle over here, and the name of the other triangle is A4 triangle. Similarly, we will be cutting the triangles A5, A6, A7, A8. Okay, all are having the height of the triangle. Each triangle is having the height L. Okay, this is also called the slant height. So I am saying that each triangle, whatever we are cutting out, each triangle is having height L. Okay. So what is the formula for area of the triangle? So area of this first triangle will be 1 by 2 times base times height, right?
Yes, ma'am.
Okay. So we are saying the formula for the first triangle is 1 by 2 times the base, as you can see. Let's say the base is whatever. Here the base is, let's say, if we are considering it as a triangle, so the base of the A1 plus base of the A2 plus base of A3 plus base of A4 plus base of A5 plus base of A6, if we will be adding like this, we will just cover this total circle, right?
Yes, ma'am.
Okay, so that means total circle, again I am saying it's the circumference of the circle, that is 2 pi r, right? Yes or no?
Yes, ma'am.
So
Yes.
let me write it properly. Area of triangle A1 plus area of triangle A2 plus area of triangle A3, like this, plus dot dot dot. Once we will add all the triangles area, we will be getting the area of the total, the curved surface area or the surface area of this cone. Okay. Now all the triangle are having 1 by 2 into base into height is L. Another one is also having 1 by 2 base, I am writing B2, height is same L. Another triangle 1 by 2 base, I am writing B3, height is L. Each and every triangle is having base whatever, but height is L. So from here we can take out 1 by 2 L common, and base 1 plus base 2 plus base 3 plus base 4 plus base 5. This will be, we will be having as a leftover term, right? Yes or no?
Yes, ma'am.
So 1 by 2 L, and now only I was telling you the base 1. Now only I was telling you this base 1 base 2, base 3, base 4, base 5, base 6, base 7, base 8, whatever is the total base, that is nothing but just 2 pi r. All of them added together will give the circumference of the circle, that is 2 pi r. Let's write it. Once we will do the cancellation, we will be having pi r l. And this is the curved surface area formula of cone. Now, if you will be focusing on the shape of cone, this is also having the curved surface area and the total surface area. In the total surface area, we are assuming that this part is not hollow. This is covered. So there is a formula for total surface area of the cone also. Total surface area of the cone, which is pi rl plus pi r square, because that is just a circular end. So this is the formula for total surface area of the cone, and this is the formula for curved surface area of the cone, which is also sometimes known as lateral surface area. Lateral and curve is a same thing. Okay, lateral means all around it and curve means also all around it. So the curve parts area is pi rl, the formula from where we got. Just for understanding, we got it after cutting it in a triangle of same slant height l. Here L is the slant height of the cone. Okay. So when we are talking about a shape cone, here we are having a height of the cone h. This is the height of the cone. Okay. This is the radius of the cone. And there is one more term over here which is called the slant height of the cone. Slant height. Okay. As the name says, it's just the slant height. Height means perpendicular height, radius already you can understand, and there is slant height also. And the curve surface area formula we got as a pi rl. So when h will be given, how you will be finding l? So you can take the help of Pythagoras theorem. Here r is there, h is there, l is there. This is 90 degree over here. So you can take the help of Pythagoras theorem once you have to find L. L is nothing but just the hypotenuse over here. That means L square is equals to H square plus R square. This relation you can use to find the slant height if height and radius is given. Okay. So this is the formula for curved surface area of the cone, where L is not the height. L is the slant height. R is the radius. If slant height is not given, height is given, then easily we can use the Pythagoras theorem to find the slant height. Got it? Is it clear?
Yes, ma'am.
Yes, ma'am.
Let's see the last figure and let's wrap it up so that we can jump to questions. We can start with the question in the next class. So the last figure is the sphere. The example of a sphere in our day-to-day life, which we can see around us, are oranges, football, any ball, or you can say globe. These are few examples of a sphere. Okay. Here we are having, if you are thinking about a football, all you can feel just by moving your hand is the curve part. So here we are having surface area. Here we don't have two different surfaces. Okay, the total surface area, the curved surface area. Here, once you will move your hand, all you can feel is the curved part. That means surface area we are having. You can also call it curved surface area. Or you can also call it total surface area. Everything is just the same over here. Okay, here we don't have any circular part. Okay. So the curved surface area formula for the sphere is 4 pi r square. Now since you have learned in every formula, from where the formula is coming. Here also let's see from where exactly it's coming. So the basic concept is, suppose we are having a top, or we are having one orange. Okay, an orange we are having, and orange is having radius here. If you, I'll mark this, it is made up of like, here we are having a circular part where r is the radius. This is how we measure the radius of the sphere. So suppose we are having an orange which is having the radius r. Now by taking the same radius, we are drawing 4 circles. Okay, you measured the radius of the orange, and by taking the same radius, suppose here you got radius as a 5 centimeter. So now what you are doing, on a paper you are drawing circle, one of the circle, another circle, one more circle, each are having radius 5 centimeter, 5 centimeter, 5 centimeter. Okay, let's see, you are drawing few circles like that. Now, if you are going to wrap, if you are going to take a, let's say thread, and you are going to just wrap the whole orange carefully, the whole orange you are going to cover with the help of the thread. Okay, just like this one. I'm taking a thread, black thread, and I'm going to wrap all around it. Okay, so that nothing can be seen. Orange we are going to totally cover with the help of the thread, like this. We just covered the whole orange with the black thread. Now nobody will be able to identify it's an orange. Once we will be showing, it's completely maybe a woolen thread we are using, the which is quite thicker one, and we have covered the whole orange. Now the same thread we are taking it out, and we are going to cover our circle. So like this we are going to cover our circle. You will find you will be able to cover one circle. More thread is left from the orange one only. You will be able to cover this circle also. You will feel okay, more thread is left. You will be able to cover this circle also with the help of thread. In work education or something, you must have done this type of things. Now you will feel more thread is left. So one more circle you will draw with the same radius 5 centimeter, and this circle also you will be able to cover. And now you will feel the total thread, the completely it's over, and you are able to cover 4 circles completely with the same thread, same length. That's why the formula for this sphere is pi r square, pi r square, pi r square, and pi r square. If we are taking the same radius and drawing 4 circles, we are able to see that this surface area, curved surface area, or the surface area of the sphere is equals to